Our plan today is to go through the comprehensive review. I'll just talk about when the test is scheduled for and so forth. So I'm going to put Thursday next week, lessons 7 and 8. So it'll be about 70 minutes, so for the whole sort of double, and 56 marks. You get your calculator, you get your page of handwritten notes, and you can bring your own formula sheet if you want to. Content is chapter 8 and 9, except the last two exercises of chapter 8, where they're not part of the course, so we don't need to assess those. And then here's a bit of a skills checklist. So this is it condensed down to what the skills are that you need to do. So we've got apply implicit differentiation. So, differentiating y equals x squared with regards to t and so forth. Solving related rates problems, solving differential equations, including those that are separable. Analysing and sketching slope fields to interpret specific solutions. Then we've got real world situations with logistic growth. So one of those will pop up in a sec, very common exam question. Then we've got parametric equations in the context of motion and curves. So that's this moving in a circle and ellipses. And then calculating arc lengths of parametric curves, what we did yesterday. Here's a summary of the revision resources. So I've given you tests 23, 22, 20 and 19. So that was an error. I printed too many of 2020 and not 21, so I can fix that. And if you need more, we've got 17 and 18, and there's some other stuff that I can find for you if you need it. But plenty to work on between now and then. So if we're happy, do you guys want to do the comprehensive review by yourself, or do you want me to go through it? I'm very happy to, just sort of wrestle through it with you, or I'm very happy to let you guys do it. What do you reckon? Excellent. Okay, so start with question 1. Differentiate the equation x squared plus y squared equals 5 to find the slope when x equals 2. Okay, so we have x squared plus y squared equals 5, and we're performing d on dx to both sides. Alright, so when we differentiate x squared with regards to x, we get 2x. When we differentiate y squared with regards to x, we're going to get 2y dy on dx, and the derivative of 5 is 0. Okay, so dx squared on dx is 2x, and d on dx of y squared is 2y, and then we have our dy on dx. Alright, so that's all good. Now we want to know what's the slope when x is 2. When the x value is 2, what's the value of dy on dx? Well, let's go back up to this equation. We have when x is 2, we're going to have 2 squared plus y squared equals 5. We have y squared equals 1. Y is plus or minus 1. We have 2 possible values of y, but we only have the one possible value of x. Now, do you guys remember what this is the equation of, by the way? It's a circle with a centre 0, 0 and a radius of square root of 5. So it looks something like this, and we've got when x is when x is 2, which is here, we've got the y value is positive 1 or negative 1. So we're talking about these points here. When x is 2, the y value is 1, and when x is 2, the y value is minus 1. Alright, positive and negative 1. And we are asked to answer the question, which is find the slope at these points. So we want the slope of this one, and we want the slope of this one. Alright, so there's 2 points where we're finding the slope. So let's do the slope first when x is 2 and y is positive 1. So I'm going to put 2 where the x is and 1 where the y is, and we're solving through for dy on dx, right? So we have 2 dy on dx equals minus 4, dy on dx equals minus 2. Alright, slope when x is 2 is minus 2, the y value is positive 1. Then we'll just repeat 4 when x is 2, y is minus 1. So we'll have 4 plus 2 times minus 1 dy on dx is 0. So we have minus 2 dy on dx is minus 4. dy on dx is positive 2. Alright, so the slope at this point is positive 2, the slope at this point is negative 2. Okay, so we've done a few skills here. That's what we do in 8A, right? So we're differentiating both variables with regards to x. Okay, any questions about that? Okay, on to the next one. Now, we have water flows into a conical tank at a constant rate of 0.3 metres cubed per minute. The tank has a height of 10 metres and a diameter of 8 metres at the top. The surface area of the water has a radius of r metres. Okay, so here's the tank. It's conical and it has a height of 10 metres and a diameter of 8, so the inner radius here is 4. And we're filling it up with water at 0.3 metres cubed per minute, and we have a radius of water r, all right, depending on how much water is in the cone. All right, the surface area of the water has a radius of r. Excellent, okay. Find the volume of the water when the water level is at h metres deep. Okay, so if this is h, all right, the volume of a cone is a third pi r squared h, where r is the radius of the base, inverted cone, the radius of the base, and the height. Okay, so that's the volume formula. Find the rate at which level h, at the water level h is rising when the radius of the water surface is 4 metres. Okay, so we have a specific circumstance when the radius is 4 metres. We're going to find the corresponding height value. And we're going to find the volume, and we're going to find the dH on dt. So if this is the volume, right, this is the volume formula, we're going to differentiate the whole thing with regards to t. D on dt. Okay, so here we've got dv on dt, but on the right hand side we're going to have to use the product rule because we have two variables, we have r and we have h. So we'll pull a third pi out the front, and then we're using the product rule for these two, r squared h. Alright, so I might make that argument here. We're going to have u is r squared, u dash is 2r dr on dt, v is h, and v dash is dh on dt. Alright, smash all that together, u dash v plus uv dash. Okay, now we're particularly interested in dH on dt, aren't we? Find the rate at which the water level is rising when the radius is 4 metres. So yeah, we're interested in dH on dt. This is the variable we're trying to solve for. So we need a few things. We know, what are we told? We're told the radius is 4 metres, so we've got r is 4. We're told dv on dt, the rate at which volume's coming in, is 0.3. Okay, so we need the corresponding height, and we need the corresponding dr on dt. Okay, so I haven't provided that variable, so I'll have to make that up. But let's go for how do we find the height when this is occurring, and this requires similar triangles. So basically we have, if we're solving through for h, we have h on r, okay, h on r is equal to 10 on 4. Now we know the radius at this instant is 4, so we have h on 4 is equal to 10 divided by 4 is 2.5, so h is, the height is 10 at this instance. Okay, so when the radius is 4, the height is 10. Alright, so let's go through. We've got the radius, we've got the height. We're trying to find dH on dt, we've got dv on dt, and I haven't provided you with this, but I should have. So let's just come up with a value for that dr on dt. Let's call it 1. Okay, so now we've got all the information that we need to solve through for dH and d on dt. So I'm just going to plug in everything we know, and then we can solve through for that variable. So we're going to have 0.3 equals a third pi times 2 times, and our r value is 4, our h value is 10, and I've said dr on dt, that's dv on dt, dr on dt is 1. Okay, so we've got 2 times our r value times our h value times our dr on dt, plus, and we have r squared, which is 4 squared, and then we have dH on dt. That's the variable we're trying to solve for. Now just be wary, this third pi is multiplying that whole thing. So if we're going to solve through for it, what I'm going to do first is get rid of that third pi. I'm going to multiply both sides by 3 and divide both sides by pi. So over here we're going to have 0.9 on pi, and then we can just simplify this. That's going to be 80 plus 16 dH on dt. Take 80 from both sides. And then divide both sides by 16. Now, in this circumstance, because I have just invented that variable there, dr or dt, try and make them look very different. This is probably going to be a negative number just looking at that, which it shouldn't be because we're filling it up, but that's because I just made this variable up. Okay, I should have provided that earlier. All right, but the skills make sense with that question? Excellent. All right, so it's a matter of just substituting in the constants and solving it through. Okay, so that's 2. Let's rub that out. Let's go to question 3 then. So that's a related rates question. Alright, so then we have a certain chemical compound decomposes at a rate proportional to the amount n of the compound remaining at time t. Suppose the initial amount is n0. Alright, explain why dn equals dn of dt equals minus kn, where k is some constant. Okay, so all we need to say is the rate of change of n, which is the number of the compound, is the amount of the compound. The rate of change of n, the amount of the compound, is directly proportional to the amount of the compound. And so what this means in terms of other syntax you will have seen, dn on dt, you've seen this symbol, proportional to n, which means dn on dt equals some value k times by n. We have a negative k, doesn't matter because we haven't stipulated the value of k either. Alright, part B. Find the equation of n in terms of n0. Okay, so it means solve through for n. So I'm going to take this equation, and this is where we're performing our logistic integral, right? So first we're going to divide both sides by n. So we'll have 1 on n, dn on dt equals minus k. Then we're going to integrate both sides with regards to t. So we'll have the integral of 1 on n with regards to n equals the integral of minus k with regards to t. So over here we're going to have ln modulus of n, and over here we'll have minus kt plus c. All okay so far? Yep, so we'll e both sides, and so we'll have n is plus or minus e to the negative kt plus c. Alright, so that's n. And then we have when t is 0, so n naught occurs when t is 0. Or maybe we'll split that up first even, actually. Let's write that as plus or minus e to the c, e to the minus kt. Yep. Now, n naught occurs when t is 0. So when t is 0, what we have is we have n naught equals plus or minus e to the c, e to the minus k times 0. This component is 1. So we have n naught is plus or minus e to the c by definition. Okay, so that means n of t is equal to n naught times e to the minus kt. Okay. So then we have, if the compound is reduced to 3/4 of its original amount in 20 days, calculate the time required for the compound to decay to 1/3 of its original amount. Okay, so we've got two parts here. First, we're going to solve for k using the information that we're given, and then we're going to solve for it to reach 1/3 of n naught. Okay, so let's solve through for k first. So we have the compound is reduced to 3/4 of its original amount in 20 days. So what that means is n of 20 equals 3/4 of n naught. Okay, 3/4 of n naught. So on the left hand side, we're going to have 3/4 of n naught, and on the right hand side, we're going to have n naught e to the minus k times 20, because we have when time is 20, we have 3/4 of n naught. Now, even though we don't know the original amount, this will occur sometimes. N naught is a variable on both sides that we can cancel. Not a variable, sorry, it's a constant on both sides that we can cancel. It's some number. We don't know its value, it doesn't matter. And then we're just solving this equation. We have 3/4 equals e to the minus 20k. We're solving through for k. So ln both sides, and then divide both sides by -20. All right, so that's using the information provided to solve for k. So there's two parts to this. Solve for k. And then the second part is, now, calculate the time required for the compound to decay to 1/3 of its original amount. So are we okay if I write this one? Yep. So we want to know what's the value of t when we have not decaying by 1/3, but decaying to 1/3 n naught. Okay, so we're saying what's the value of t such that we have 1/3 of the original amount? Well, we're just solving this equation, n naught e to the minus, now we know the value of k, minus 1 on 20, ln of 3 on 4, t. Now this can be simplified, but it's not something that we have to do, right? You can take that to be a power, and then e and ln will cancel. It's not something that we have to do, though. We're solving through for t when this is true. We're trying to solve for t. All right, so at the moment we've got n naught on both sides. Now, firstly, is everyone okay with how I've set the equation up? So what have we done? We've said, this is we solved through for k, so this is the equation for the number of the compound. All right, with the value of k put in there. And we're saying, what's the value of t when the number of the compound is 1/3 of its original amount? Okay, so n naughts on both sides, we'll cancel it. Perform the natural logarithm of both sides. So over on this side, we're going to have minus 1 on 20 ln of 3/4 t. And then we'll divide both sides by this component. So we have ln of 1/3. On top will be minus 1 on 20 ln of 3/4. All right, so what we've done there is we've found the value exactly. Okay, so that's the kind of complexity that you are expected to perform, finding the value exactly, and then we can evaluate it to 3 significant figures if we need to. Another way it could be done is by like graphing this equation and g solving the t value when it equals a third. That won't give you the exact answer though, that will only give you three significant figures. Okay, so that's a good summary of chapter 8. Now chapter 4 is a good summary of everything in chapter 9. It's a good problem solving question. This is an old exam question. Does anyone have any questions about 3 though before we move on to 4? Alright, so yeah, this is just a good all round question because it combines a lot of things that we've done. So we have the position of a comet. A planet is positioned at the point 0, 0. So the planet is here, and we have the path of a comet approaching the planet is represented by these parametric equations, where t is time. Sketch the path of the comet. Okay, so that's straight away a calculated job. We have a parametric equation. We've got a constraint for t, so let's all make sure we know how to do that. Graph, and I've got, now sec t is 1 on cos. So we have 2 on top of cos t, take 1 for x. And we have square root of 3 tan t for y. And v window to standard, and t is going from pi on 2, make sure you restrict your t value, pi on 2 to 3 pi on 2. From pi on 2 to 3 pi on 2. Alright. So this is what we've got. Wonder how much do I need to zoom out there? It's sort of doing something like this. Okay. Excellent. At what time is the comet closest to the planet? Okay, so it's going to be closest at this point, right? We can see that very clearly from our graph. All right, now, whenever you're required to sketch a graph in tests and exams, we provide the Cartesian plane, right? So you already have a V window over which you can place some restrictions. So sketch the path. At what time? So we want to know the time value when that occurs. Now, we're not asked to find it exactly, which means we can just sort of trace along it. So pi. All I'm doing is tracing along, and when time is pi, it reaches the coordinate x is minus 3, which is this coordinate here. X is minus 3, y is 0. So the answer to part 2 is t equals pi seconds. Alright, so that's something we can just get straight from our calculator. 3.14 is fine as well. Like another way to answer it, like if you think about it, so let's just talk about a couple of ways we can answer that. So you're always looking at different ways of thinking of it. We have 2 sec t, take 1. So this is 2 on top of cos t, take away 1, right? Where this occurs, it's going to be closest to point 0 when x of t is the smallest value, when it's closest to 0. So that could be a matter of looking at just that function and saying, when does it have the x value minus 3? When is it closest to 0? What's the minimum point on this function? Sorry, it'll be maximum because it just keeps getting further away. What's the maximum point on that function? So that would be one way of answering it as well. All right, let's not get bogged down. At what time done? On the axis, mark a point A, the position found. All right, so this is point A. So we have point B and we have point A. Okay, show that dy on dx is equal to this. So we want to differentiate. So if we want dy on dx, all right. Now, dy on dx, that's going to be dy on dt on top of dx on dt. right, so we're going to differentiate both of them with regards to t. So we start with x of t. Now, even if you can't remember the rule for differentiating cos of t straight away, what we should be looking at is using the chain rule, cos of t to the minus 1, and we have this take 1 over here, right? So all I've done straight away is express it as the power at the top with the negative. Okay, so now when we differentiate this, we're going to have negative 2 cos of t to the power of minus 2, minus 1 take 1, multiplied by the derivative of cos of t. Now when you differentiate cos, you get negative sign, and then we've differentiated with regards to t, haven't we? So that's fine, we don't need any d on dt. So that's x dash of t. Alright, is that okay how I've got that? Yeah. So then we'll do dy on dt, which is, you know, the y function is, where is it? Root 3 tan t. Alright, now even then, like, what's the derivative of tan? I've got it written down somewhere, but tan is sine on cos, sine x on cos x, sine t on tan t. So it can be a can be a quotient rule. I think it's 1 on cos squared. I've got a formula sheet here somewhere. Anyone remember? I'm just going to have to evaluate it. So we have u on v. So just to refresh you on the quotient rule, we have u on top of v. The derivative is u dash v, take away u v dash. Alright, now the derivative of sine t, so let's write them out. U is sine t, u dash will be cos t, v is cos t, v dash will be negative sine t. So we have u dash v, alright, u dash v, which is going to be cos squared t, take away u v dash, all on top of v squared. Yeah, I was right, cos squared t. Now, two negatives make a positive, so we have cos squared t plus sine squared t on cos squared t, which is 1 on top of cos squared t. Okay, so the derivative of tan of t is 1 on cos squared t. So if we have root 3 tan t, then, so there's x of t, there's x dash of t. We have y of t is root 3 tan t, and y dash is going to be root 3 times 1 cos squared of t. Okay. Alright, and we can distribute the root 3. Anyway, we've said dy on dx is dy on dt on dx on dt. So all we're going to do is dy on dt on dx on dt. So that's going to be root 3 on cos squared t on top of. Now I might simplify this one as well as a fraction. So that's going to become positive 2 sine t, okay, the negative and the negative. And then at the bottom we'll have cos squared t. Alright, so that's how we're bringing all that together. So this is dy on dx. This is the rate of change of y with regards to x for the common. And then we have AD on BC, AD on BC. So that's root 3 cos squared of t on top of 2 sine t cos squared of t. Cos squared of t can cancel. QED. Root 3 on 2 sine t. Alright, so there's a fair bit involved in that. Show that dy and dx is this. Everyone okay with how we've generated that? I probably dragged it out a bit because we'll have that formula written down on our formula sheet, on our cheat sheet. And the same with this one as well. Okay, so that's B part 1. Okay, part 2, for t equals 5 pi on 6. So we're going to put in, we've got speed doing this because we're in recess. t equals 5 pi on 6. Alright, so what I'm going to do, I'm going to put this t value into our dy on dx equation here. So we have dy on dx is going to be root 3 on top of 2 sine of 5 pi on 6. Now sine of 5 pi on 6 is over here, positive half. So we have root 3 on top of 2 times a half. That's just root 3. Alright, on the axes, show the result of B part 2. So when t is 5 pi on 6, so we can, if we're tracing along it, we can input the t value, 5 pi on 6, and it's just here, and it wants us to illustrate that result. So we found the slope at this point. We can get rid of that coordinate. The slope at this point is root 3. That's how we illustrate it. The slope at that point is root 3, and t is 5 pi on 6. Okay, that's how I've done that. Okay, show that the speed of the comet is given by this equation. Well, speed is the magnitude of velocity, right? So it's the square root of x dash of t squared plus y dash of t squared. So we've got x dash of t, I wrote them out, but x dash of t was this one. Yep. So we'll have 4 sine squared t on cos to the power of 4t. So that's x dash of t plus, and then we have y dash of t is this one. So that's going to be 3 on top of cos to 4t. We'll just crack this part out. Oh, we got 2 to go. So we'll get it done in a sec. Alright, so we're happy, all we've done is put x dash of t squared plus y dash of t squared. They have the same denominator, so they can come together. So it's 4 sine squared t plus 3 at the top. And we're just splitting the square root. Cos to the 4t, the square root of that is cos squared of t. So that's QED. Alright, so that's show that the speed is this. And then for the last part, hence find the distance travelled. Okay, so this is 9f. Now distance travelled is just the integral from a to b of the speed function. So we're doing the integral from 2 pi on 3 to 5 pi on 6 of the speed function. This one here. Root 4 sine squared t plus 3 on top of cos squared of t with regards to t. So we're just going to type that into our calculator. Now remember, when you type that in, we want to convert it, we don't want it in parametric form. So you need to change the function in your calculator to be y equals, because what's it called, not the period, when you change the sequence of the t value, the number of iterations. Anyway, that has an effect on it. So that's why we just want to convert it back to y equals. All right, change this. So I'm happy to type this in. All of this makes sense. We remember doing all of these processes. Yeah, so a pretty comprehensive summary there. Any questions from you guys at this stage? No. All right, enjoy your recess and we'll come back and then you can dedicate your efforts where you feel like it. I'll type in this answer and then you can have it when you get back. Enjoy.
You just erased a little bit.
Oh, sorry. Yeah. Let me just put this in and then I'll stop the video. From 2 pi on 3 to 5 pi on 6. 2.62. 2.63 units. We're not giving any units, so that's what it's going to be. 4 sine squared from 2 pi on 3 to 5 pi on 6. Yeah, 2.62, because that's from like, yeah, year to year. So it's not very far.